So when we are mapping a texture to an object, there are different ways to do this mapping. Let's say we have a small texture, okay, represented by T, and we have a large object, okay, a rectangle. Now, when we map this texture, so this is our texture, this is our rectangle onto which we want to do the mapping. So one approach is to enlarge this texture to fit onto our triangle. I mean, how do we do the enlarging? So we simply say, let's say these are our texture coordinates, okay, so this is the 0, 0 of the texture, and this is the 1, 1, the bottom right corner of the texture. So we say 0, 0 maps to here, and 1, 1 maps to here. Okay, these are the texture coordinates of the vertices. Of course, we can define them in a similar way. So this maps to here, this maps to here, this maps to here, and then this maps to here. So the effect of this is going to be enlarging of the texture image. So this T will appear enlarged on our model. Now, sometimes we want that, sometimes we don't want that. Now, one alternative to this resizing is known as tiling. So in tiling, we want to generate multiple copies of the texture on the object, okay, without resizing the texture. So again, let's have the same texture T, and we want to map this onto a rectangle. Okay, so in tiling, what we want is this T to be duplicated, okay, repeated basically. So in this example, we are repeating 4 copies of the texture along the horizontal and 2 copies along the vertical. Now, how can we accomplish this? Let's again write these coordinates. So this is 0, 0, and this is 1, 1. So what we can do is we say this is 0, 0. We want 4 copies, right? So what we want here is along the horizontal 4, and along the vertical we write 2. Okay, so in this case you can see that the texture coordinates are no longer in range 0 to 1. So we have given 4 and 2. Okay, so this is a possible. This is possible. Then imagine that after computing the coordinates, let's say, for example, we have a point here. Okay, P. We want to compute the texture coordinate of this point. Okay, so let's say, so the halfway point would be 2. Okay, so from 0 to 4. And this would be like 1. Okay, so let's draw here. Okay, so this point would be like 1, because 0, 1, 2. So what is this coordinate going to be? This coordinate is going to be something like 1.3, let's say. Okay, so let's say P is 1.3, and let's say it is 1.6. Okay, so now, but we said that our textures, the original texture is the coordinates of the corners are from 0, 0 to 1, 1. So how do we map this P, the coordinate of the P, onto our texture? Okay, so we basically, to accomplish this mapping, note that we are interested in trying to get this point. Okay, we are trying to get this. But we have actually, our point P indicates 1.3, which is, if you go along this axis somewhere here, and 1.6. which is, if you go along this axis somewhere here. So our point P ends up being outside. Now, to do tiling, we simply subtract the floor of these fractional values from the values themselves. Okay, so the texture coordinate is going to be, let's say UP, is going to be the value, Okay, so let's call this is UP prime and this is VP prime. It's going to be UP prime minus floor of UP prime. Okay, and similarly VP is going to be VP prime minus floor of VP prime. So as you can see, floor in this example is going to be 1 for both of them. So the result is going to be, after computing these, doing these subtractions, we are going to have 0.3, comma 0.6. Okay, so we basically go like this, and we find this value. Okay, so for tiling, we do two things. We allow the texture coordinates to be outside of the 0, 1 range on the model. And when we need to look up into the texture, we subtract the floor of the texture coordinate from the coordinate itself to find the point inside the texture.